Hello, this is Chemistry, the Central Science. This is 11th edition book. We're in chapter 2 on atoms, molecules, and ions. And we're question number 47 in the end of the chapter. Write the molecular and structural formulas for the compounds represented by the following molecular models. So we have a couple different models here. The top two, A and B, are ball and stick models. Usually, conventionally, black is representing carbon, and red is representing oxygen, and white is hydrogen. It's the same with B. C and D are not different types of chemistry. It's just instead of the idea of a stick, which is really not based in chemistry, it's based in the toys that we have in the lab to play with, where we have little wooden balls or little plastic balls and little sticks to connect them together. This is the idea that this is a region of space and that they're overlapping, that the electron cloud that's around each of the neutrons the nucleus is overlapping, and that they're sharing electrons. That's what a bond is. A bond shares electrons. So they're kind of forced together with the idea that they're still spheres of electrons that are surrounding each of these nuclei. Okay, so C also would be red is oxygen, white hydrogen, black carbon. D is also a space-filling model, but they've indicated it as phosphorus and fluorine. So we're asked to find two different formula, molecular and structural. So molecular is just what atoms are there and how many of each. So let's look at A. So the molecular formula for A is going to be 2 carbons. Okay. And then we have how many hydrogens? 1, 2, 3, 4, 5, 6 hydrogens and 1 oxygen. That's the molecular formula for A. How about B? Well, I've got 2 carbons. Hydrogens, I've got 1, 2, 3, 4, 5, 6. And O. Okay, interesting. These are the same figures, but they're arranged in different ways. That's why that a molecular formula is not always not everything you need. Like C2H6O can be configured in different ways, and sometimes that configuration can depend upon whether it chemically reacts or doesn't react, okay, or how it reacts. Okay, so that's why molecular models, these models or pictures of how the atoms are actually structural formulas, are very useful or helpful to you. Okay, let's do C. C, I've got looks like I've got 1 carbon, 1, 2, 3, 4 hydrogens, and 1 oxygen. Okay, and you can write that a couple different ways. That's an alcohol, so you could write CH3OH. That's another option. I'll put this in parentheses. CH3OH. Okay, methanol. This is wood alcohol. And the last one, D. I've got P, and I've got 3 Fs. Okay, that's the molecular. Structural, we are looking for a center atom that everything is going to connect to. Well, you don't even need, this is cheating because you've got the picture right in front of you. Okay, what is this looking like? Instead of 3-dimensionally, you're just making it 2-dimensional. So I'm going to start in the center. So I've got the oxygen. It's each attached on both sides to a carbon, and then that carbon is attached to 3 hydrogens. So hydrogen, 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 hydrogen. Now, you can study this a minute to see if it makes sense, but O, we've got O is here, then the 2 carbons are here, and then 3 hydrogens attached to the carbons each. Okay, so that would be A. What would B be? Okay, I've got carbon, carbon. Then on this side, I've got H, 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 Okay, this side I've got H, H, then it attached to O, and there's an H. There's another alcohol. OH is an alcohol. Okay, how about C? I've got one CH3. Okay, then I've got the O, and then I've got the H. That's why sometimes this would be the preferable formula. Even though they're RC, all the H's together, that's totally fine. But to help you think it through so that you can translate the molecular into the 3D in your head. Last one, real simple. You've got a P and 3 F's. And they're trying to stay away from each other. Okay, I hope that helps.